In yesterday's class, if you notice it, we discussed what is laws of motion and as well as what are the types of forces and all. So in that mainly one non-contact force and one contact force we are keep on stressing. That is what the first type of force. What is the forces? Non-contact force, very important. That is what we used to say gravitational force. So which is only we are going to study in our class 11th. And as well as one of the contact force. What is that force actually? Two actually. One is tension and another one force is what? Everybody? Normal reaction. So that is what we are going to discuss. So in this, the main things, if you notice it, so as we all discuss what is the force and how to find the directions of tension and all yesterday's class. Now we will continue here. So I think I have taught you till free body diagram. Am I correct, everybody? The free body diagrams. Am I right? All of you?
Yes.
Yeah. So let us see now. Today we'll discuss what is the gravitational force and as well as normal reaction as well as tension. And then mostly we'll discuss Newton's first law also in our today's class. So first, all of you keep heading gravitational force. So this gravitational force is not new at all to you people. So which already you people studied in our class 9th gravitation chapter. So class 9th, if you see that, always you can take like the force acting between any two bodies, universal law of gravitation or Newton's law of gravitation. Have you heard it? Gravitation chapter in class 9th. Before Kepler's laws, we studied universal law of gravitation or Newton's law of gravitation. Any one of you? Yes. So that is what. So let us see that if you consider if this is the earth. So if you are not remembering, that is why I said you to revise the 9th class physics. So as we all know, if the body is anywhere in this, always we know that the force of attraction of this body who is having mass m. So any point, the always some force is acting, pulling towards to the center of the earth. So that force only we used to call as, what is that actually? Which is equals to weight of the object. That is what W is equals to how much, guys? Everyone? W is equals to respond. W is equals to what? mg. So that g only we used to called as, what is g is called as? Acceleration due to, nobody is speaking. I don't know what you people thinking. Can you hear me at least? Acceleration due to gravity. That is. So if the object is here or here or here, whatever it is, if you take any object, you can see every object will fall towards to the center of the earth because of some pulling force is acting always towards the center. That pulling force only we used to call as what? Acceleration due to gravity. So if you see the class 9th, if you go back to the class 9th, you might be remember that if, for example, this is what my hand, I want to carry 100 newtons, 100 grams of force in my hand. So what is the force I need to apply on my hand to not to drop that? You might be remember that 100 grams of force, if I want to hold it, I need to apply 1 Newton force. Remember, brothers, that is what define one force we used to study. Define 1 Newton. So like that, if you want to hold the 1 kg mass in our hand, so what is the applied force? Approximately it is equals to how many newtons? Everybody, 10 newtons, because 100 grams into 10, which is equals to how many kgs? Everybody, 1000 grams equals to how many kgs? 1000 grams is equals to how many kgs? 1 kg. So if you want to hold 1 kg mass, which is equals to how many grams? How many newtons force you have to apply? Which is equals to 10 Newton force, or approximately how many newtons force we have to apply, guys? If you want to hold the 1 kg mass in our palm, which is equals to 9.8 newtons. That is only 9th class used to study. Acceleration due to gravity. Even 11th class we studied. What is the G value? Everybody. Either 9.8 meter per second square or we will say 10 meter per second square. So that is what you have to remember. So if you go back to the gravitational force, that is what the force exerting between any two bodies. If you take any two bodies in the universe, always the force is exerting between them. So that force only we used to call it as gravitational force, which is equals to weight. What is the gravitational force actually? We used to call it as what? Gravitational force means weight. Understanding? So weight is equals to force. So how to calculate it? For example, this is one object and this is another object who is having mass capital M and another mass is small m. And the distance between from their centers. Do you all remember 9th class? By this time, you might be remember that. Distance between their centers is, let me take dr r. Let me take, okay, distance r only we can represent. So then the force between any two bodies in the universe, that is what we used to call as universal law of gravitation. Any one of you remembered at least name? Universal law of gravitation. Nobody? Yes, please.
Yes, sir.
Yeah,
Yes, sir.
universal law of gravitation. So class 9, that is why whenever free, please at least go through once. Universal law of gravitation will says that F is directly proportional to product of masses and F is inversely proportional to square of distance from their centers. So this is only we used to call some law. This inversely proportional to square of
square root.
Yeah, inverse law, inverse square law, inverse square law we used to call it as. Am I right, Pradosh? 9th class. So that is the reason 9th class is the foundation for 11th class physics, we'll say. So if we combine these two equations, we'll get something. So what is the formula? F is equals to capital G into capital M into small m divided by D square or R square. Let me take D is equals to R, whatever it is. So we'll take it. R means our distance between from the centers, or D also distance between from the centers. So this is the formula to calculate the gravitational force. Gravitational force only we used to call as what? Everybody. We used to call as
Wait.
weight, which is acting between any two bodies on the object. That is what you have to remember. So this is what is gravitational force. Okay. Now, so let us discuss the next type of force, which is very, very important. That is what? Normal reaction. Yesterday itself, you might be all understand. So normal reaction is always perpendicularly to what? Perpendicularly to the gravitational force. That is what? Weight. Am I right or wrong? Everybody, please respond, guys. All of you?
Yes, sir.
Yes. So most of the cases, 99% cases, remember, normal reaction is existed only when the objects are in contact. Understand, Rudreswa, Pradosh? When the objects are in contact, only the what force is existed, everybody. Normal reaction is existed. Okay. So let me consider now, this is one surface. Let me take it, all of you observe very carefully. This is what, everybody? This is one surface. Now some object is kept on it. You can observe very carefully. Some object is kept on it. Now who is having a mass m? Now tell me, what is the weight of the object? Weight of the object will act downward direction. So W is equals to what, everybody? W is equals to respond, guys. Mg.
MG.
Now, if I take the normal reaction which is exerted by the surface on this object, understanding, which is always perpendicular to surface. So normal is always perpendicular to what, everybody? Perpendicular to surface, which is how much angle? Everybody, angle is equal to how much? Perpendicular means 90 degrees.
90.
And also perpendicular to point of contact. Perpendicular to what? Point of contact.
Point of contact.
So wherever it is contacting, there it will be perpendicularly to the point of contact. Now, this normal is the force, normal reaction is the one which is exerted by surface on the block. Do you all understand, everyone? Normal reaction is the force which is exerted by surface on whom, guys? Surface on block is that. Then if surface is exerting normal force on this block, then block also will exert normal force on surface. So it will be exerting in what direction? Everybody. It will be exerting on, yes, please, downward direction. Understand, Pradosh, Rudreswa? This normal reaction is exerted by surface on block, and this normal reaction is exerted by block on, everyone, block on what? Surface. Okay, so that is what you have to remember it. Now, for example, let me consider inclined surfaces. So we all know inclined surfaces. So if I consider the inclined surface, so all of you observe. Now, we all know the inclined surfaces. We are all familiar with that. So inclined surfaces, object is just riding. For example, imagine this is only, so I'll make it. So if you all notice, always we will consider this is a very beautiful case. We all remember. So object is, for example, this is the object. Now, so we all knows that this is the mass m. So normal, which is exerted by the surface. Let me consider this is the surface now, all of you. The normal force which is exerting, always what I said, it must be how much angle? It must be perpendicular. Understanding? 90 degrees. See, this is the surface to the mass of the object. This normal is the surface to the block. Then block is also will exert normal on the surface. Then that will be acting what direction? Everybody. It will be acting in the opposite direction. Clear, everyone? So first one is what? Surface to the what? Surface to mass m. And what is this one, everybody? Mass to what, everyone? Mass to surface. That is what you have to remember. Normal reaction. How it will be normal reaction? Because, sir, why, sir, like this? Keep in mind, forces cannot exist independently. Forces always exist in pairs. How the forces are existed, everybody? Forces are always existed in. Yes, please. Four.
Pair.
Okay, pair. That is what you have to remember. Now, let me consider now circular motion. For example, I am having a circular path. Who is having a center R? So that let me fill it with a color so that you all clearly understand. So this is my circular track. So we all know it is having a center point. Let me take point O. Now, if you all notice it here, one body is present. Okay, or you consider this is the earth. Okay, what is this, everybody? Earth. Now, the object is present here, which is having mass m. Now, the earth is the surface. So now the surface is the normal reaction, which is exerted on this body, which is always acting what direction, everyone? Upward direction. So this is what the normal. Then the mass is exerting the normal force on this surface. That normal will basically is definitely will pass through the what, everybody? It will pass through the respond. Pass through the what? Center. Clear, everybody? So it will pass through the what? It will pass through the center. Clear? So let me consider here one more block is there. Now, at this surface, the force exerted by, normal reaction exerted by the surface on this mass will act in what? Perpendicular direction. And this mass is exerting the normal reaction on the surface, which is that line. Sorry, let me take this is like this. Perpendicular. So perpendicular means must be 90 degrees. Then the normal reaction which is exerted by mass on the surface, which is also will pass through the what? Everybody. Which is also will pass through the center. Okay? Understand? Sudreswa? Always?
Yes, sir.
That is what. So forces are always exist in pairs. That is what you have to remember. So this is what the second one, normal reaction. So two important points. So normal reaction means it is perpendicular to surface, first thing. Second one, perpendicular to point of contact. Wherever it is contacting, at that point also, it is acting perpendicular. That is what you have to remember. Hope everybody clear? Any doubt anybody can ask. Okay, guys? Hello?
Yes, sir.
So next, tension. So we are all very familiar. Tension means immediately you have to remember one word. Can you tell me any one of you? Tension is existed in where? String. Am I right or wrong? All of you. Yesterday also we discussed it. So same the string, same will be the what? Same the string, same will be the
Same tension.
Until the string is remains same, the tension in the string is always remains constant. So tension is actually a force. We all knows that the tension is the force which is always acting what? In a circular path. When the object is in circular path, the tension is the force which is always acting on the what? With T is equals to, we have done it. T is equals to what? Everybody? Centripetal force. Do you all remember that? The force which is acting towards the center, which is equals to tension. So always the force the tension will act along the string. Along the string, it will act and always act towards the what? Everybody, it will act towards the response center. Okay. Now, so if you take a string, rod, chain, or whatever, etc., this tension is same. So let us observe now. One string is attached to the rigid surface and it is having a mass m. Attached some mass. So that is what mass m. Now, can you tell me weight is acting what direction? Weight is acting downward direction. That is what? W is what? Fastly. W is equal to mg.
MG.
What about the tension? Keep in mind, tension we already knows. Tension always act what? Away from the point. Tension is always act away from point. So now this is what my point here. So tension will act like this direction or downward direction, everybody. It will act in the upward direction.
Upward.
Okay. So that is what you have to remember. For example, let me consider this is what my surface and I'm having a mass m. What is this, everybody? Having mass m. Now, all of you observe, has been applied a force some F, means in the sense of now tension direction. What is the tension direction? Direction of tension is also along the direction of what? Along the direction of force. That is what it will move away from that, away from the object. Always tension T moves away from point. That is what you have to remember. So unless string change, what will happen? Once the string will change, T also will change or remains constant. Everybody. If the string will change, then what will happen? All of you, T also will change. Okay. So that is what you have to remember. For example, let me consider the two bodies now. The body one is M, this is M2 body and this is the M1 body. Now, this is the direction of force which we are applying. Okay, everybody. Now tell me. So as we all knows that here at this point, let me consider now what is the direction of tension, everybody? Away from the body or towards the body? It will act away from the body. So let me
from the body.
That is next. At this point, tell me, at this point also it will act away from the body. So that it will act in the direction of M2 or direction of M1, everybody? It will act direction of M2, like this only. Am I right or wrong? So let me take, definitely we know that here string is changing. So tension will change or not? Here I have taken tension is T. Then now here string is changing. So tension will change or not, everybody?
T1.
T1. Then here also it will move away from that. Then here also what is the tension, everybody? Because same string again. This string and this string is not same, but here and here the tension will be same in this string. Is it okay, everybody? Clear, understand?
Yes, sir.
Yes, sir.
Yes. So that is what you have to remember. So wherever you want to find the direction of a tension, just you always try to imagine you are standing or sitting in this and you put one, if it is two bodies like attaching, see this middle body is attaching two directions. So one is T and another one is D dash. Both is moving away from that. Okay. You can assume Manya. Here, if you want to assume T1, then you can assume T2. Manya is asking, sir, why can't the first thing is T1? Your choice. If you assume here T1, then here what will come, guys? Everybody. Here it is what? T2. And here also what will become? It will also become, all of you, T2. Understand, Amma? That is what. So your choice, Manya. There is no restriction for that. Clear? All of you. Yes?
Yes, sir.
That is what. So always remember that. Whatever, if you want to find like many objects, let it be. So many bodies are attached, you can take it. So this is what. So let me take 4 bodies are attached and now here is the direction of force. So can you tell me what is the directions of T1, T2? Tell me. So here what will happen? Moving away from that T. Now here also moving away from that, it will take it as same string. This and this is different string. Then here both are same string. Here also what will come? T1. Again different string. Here what will come? Everybody, T2. And here also same string again. Here also what will come? T2. And here different string. What will come? T3. Here different same string. It will also will come what? T3. But that is what. Do you all understand, everyone? Clear? How to find the tensions? Direction? This is what you have to remember it. Okay. So please make it. Now, So always you have to remember, whenever you want to find a tension, just imagine you are standing here and you can see that if it's the same string, same tension. If it is opposite, another where string is varying, tension is also varies. That is the only you have to remember. So always keep it in mind. T always act what? Very important point. T always, what is that? Away from the point. Clear? So yesterday I have taught you free body diagrams. We have to consider the entire body as a point mass. Am I right? Everybody?
Yes, sir.
Yes, that is what
Yes,
you have
sir.
to remember it. Now, so keep it in mind always, whenever they are giving the string, according to your class 11th syllabus, always remember the string is considered as a massless string, means negligible mass. Almost it is having what? Everybody? Massless string. Entire class 11, the string we will consider as a massless string. So almost in most of the cases, 90% cases, T remains same or difference? Everybody? Same.
Same.
Remains same. Okay. So when until the string will change, until the string remains same, the tension is also what? Everybody? The tension is also remains same. Okay, most of the 90% cases, the T's remain same until the string is remains same. Okay, everybody. So now, for example,
Yes, sir.
let me take one more example. So this is the rigid surface I have taken. Observe very carefully now. Let me take this is the body. Now from here, this is another rigid surface. Now, can anybody tell me? Rigid surface also will exert tension on this. Now, the tension exerted by this first one, which will goes away from it, which is considered as a T or T1. Then here also it is moving away from that. That is the same string or different string. I verify different string means changes. Same string. Then here also what will come?
T1.
Here also
T1.
now here, this is will move away from that, but different string,
T2.
so that it is T2.
T2.
Now here, this is also different surface, so this is also
T2.
so that is what.
T2.
So you have to find the tension in this such a way direction. Always it will move away from the point. And yesterday I have taught you two things before free body diagrams. We have been found the normal force in that wedge J, and as well as two bodies are hanging between the two stationary points. That all we have found the direction. Do you all remember? All of you?
Yes,
And free body diagram totally how many steps we have? Free body diagrams, everybody. Free body diagrams totally we have 3 steps. Do you all remember everybody? All of you?
Yes, sir.
Now we have to find it. That is the reason. Okay, let me consider now. So how many of you know pulley? I told you to drain the water from the well and all. Olden days they used to use the pulleys. Of course, now also for lifting the heavy loads and all, we people will use the pulleys only. Do you all notice it, everybody? All of you?
Yes, sir.
Yes. Now let me consider the pulley is attached to the rigid surface. The pulley is attached to the rigid surface. Okay. And another kind of a rope or a thread which is passing through the surface, which has been attached first. M2 mass. What is the mass of this object, everybody? M2. And another mass of the object, which is called as M1. Now, so let me consider like yesterday free body diagram. Now we all know if I consider mg as a point object, M1, then what about the weight of the object, everybody? Weight of the object will act downwards or upwards? Everybody will act always
Downwards.
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 Everybody? Then, so I will mention here. So weight is acting downwards, means in the sense of the tension of the string here. You can see this tension, this thread is made up of same string. Am I right or wrong, everybody? This
Yes,
entire thread is made up of what? Same string or different string, everybody?
Same string.
Same string. So if it is the same string in the sense of tension is same or tension will change, everybody?
Tension is same.
Tension will same. So here also tension is same and here also tension is same. Am I right, brothers? Laksha, understand, Mr. Rishi, Sai Karthik, anything doubt, ask me. Because why? This entire rope is made up of same tension. Am I right or wrong, everybody?
Yes, sir.
Yes, sir.
That is what. So here also tension T and here also tension T. And here also weight is acting downward direction. That is what. Let me consider this is M1G and this is what? Everybody. This is M1G and this is what? Everybody.
M2G.
M2G. Now,
M2.
what are the forces acting? Let us make it into free body diagram. FBD. So this is what my M1. So the weight is acting downward direction and the tension is acting what? Everybody. Tension is acting in the no response. All of you. Upward direction.
Same.
Next, same way,
Upward.
object 2, consider object 2, mass 2. One force is acting downward direction, mg2, and another force is acting upward direction. That is what we used to say. What force it is? Everybody.
Tension.
Clear? So that is what you have to do. Any doubt for anybody? You can ask them. Clear? Now, as I told you, the string mass is almost like entirely it is considered as a what? Massless. See the string what we are using to drain the water, entire class 11th and 12th will consider it is almost already I told you it is a what? Massless. Understanding? And even we will consider it is a frictionless. What is that everybody? It is the frictionless. Okay. So that is what the mass of the thread what we are using here almost it is negligible mass and it is having a what we can say that different kind like zero friction for them, almost negligible. That is what you have to remember it. Okay. So now observe very carefully as this entire rope is made up of the same string, so that we can say that tension is same, but we are using some other rope to tie the pulley to the rigid surface. Can you have noticed it, everybody? Yes, please. Definitely this string and this string is not same.
Yes,
Then here also, if you consider P is my point object. All of you observe very carefully. P is considered as a free body diagram. One side the tension is acting downward direction. Another side the tension is acting also downward direction. But somebody is acting upward direction. Is it definitely a T or some other force? Everybody, some other tension. Definitely it is a what? T1. Why it is T1? Anybody can tell me? This is also string only, correct? But why it is?
Different string.
Because we are using a different string to tie the pulley. Ellame puriyuma? Different string.
Yes, sir.
Tie the pulley. That is what. So if I consider pulley is my point object like a free body diagram, one tension is acting upward direction, that is what T1, and two tensions are acting downward direction. As it is same string, tension is what, everybody? Tension is strain. That is why we will consider this. Do you all understand, everybody, free body diagrams? Yes or no, please? Manya and
Yes,
Samaya?
Yes, sir. Yes, sir.
That is what. So everybody should know. Asida, understand? So this is what about how to make the types of forces and free body diagrams. Now we will enter into the first heading of this chapter. That is what we used to call as, what is the first law? Newton's first law, which is called as Newton's laws of motion. All three laws together we used to call as Newton's laws of motion. In that the first law, what is to call, all of you? The first law we used to call as Newton's first law. Okay. So also we can say many names. Newton's law of inertia. Okay.
Yeah.
Newton's law of inertia. Or we can say also, what we can say? Galileo law of inertia. Galileo law of inertia. So these all the things are same name. Newton's. What is that law? Everybody? Newton's
First
first
law.
law. So keep it in mind, Newton's first law means, let us go back to the 9th class and remember, one object is in stationary, which is object in rest. Another object is in motion, uniform motion, okay, along its path. Okay, uniform velocity actually. It is moving with the uniform velocity. It's not uniform motion. What actually it is, everybody? Uniform velocity. So, what Newton's first law will say is, for example, I want to make this body from rest to move. So definitely you have to make it something. What is that? You have to apply what? All of you. You need to apply the force. Yes or no? So, yeah, due to the force, external force. Yes. So due to the external force, the body which is in state of rest will turns into move. Same way when the body is in uniform velocity, if you want to increase the velocity or decrease the velocity, or you have to stop it. Definitely, here also we need external force. Am I right or wrong, everybody? Please respond.
Yes, sir.
All of you, that is what. So that is what, whatever the external force, unless until an external force is applied, the body which is in stationary remains what? Remains in state of rest, so that no further, there is no, if there is no external force, no displacement or whatever it is, if you notice it, the body is always remains to state of rest only. Now, some bodies are moving with what velocity? Everybody verify this. Some velocities are moving with what velocity? Uniform velocity.
Uniform velocity.
If you want to stop your car, or if you want to increase your speed or uniform velocity, now you tell me. So, is it needed external force or not? If you want to increase the car speed, or if you want to decrease the car speed, or whatever it is. So, do you need to increase the accelerating or not? Suppose your initial velocity wants to make it into something final velocity. Now, do you need to increase it? So that definitely you need to apply the external forces or not? Everybody respond, Ra.
Yes,
sir.
sir.
That is what. So, unless and until a body which is in state of rest and the body which is in state of what? Uniform velocity or in state of uniform motion, then if you notice it, what will happen? Unless they compelled by an external force, the body which is in state of rest remains rest. The body which is in state of motion remains motion. Okay, so that is only we used to called as Newton's first law, which we used to called as F net. Net force must be equals to 0. Then only it is Newton's first law. Do you all understand, everybody? So means in the sense of Reddy sir said rest means no force is acting on them. Do you think that no force is acting if the object is in state of rest? Definitely something. Weight of the object is acting downward direction. Next. Yes, please. Something opposite to that, which is called as normal reaction is acting
Normal.
what? Normal reaction is acting upward direction. For example, a man is trying to apply the force in this direction. Still, the body is no displacement. No displacement means in the sense of the force exerted by this man, is it sufficient to move this block or not sufficient to move this block? Everybody.
Not sufficient.
Not sufficient to move this block because by the time the force is acting opposite to the direction. So whatever it is, totally if you add, total net force is equals to what? Everybody, net force is equals to remains, respond, 0. So that is only called as Newton's first law. If force is 0, we all knows that there is no change of state. That is what? Then acceleration is also what? Everybody, acceleration is equals to also 0. Why?
0.
Because state change
No
is
change.
not possible. Do you all understand it? So state change is actually not possible because if you notice it here, as it is noticed, totally it is net force. Whatever, see, in this body totally 4 forces are acting, including the frictional force. But still there is no displacement in the body. Means in the sense of this, all the forces are said to be what kind of forces? 9th class, anybody? Which is called as, all of you,
Balance.
balanced forces. That is what you have to remember. Clear, everybody? Understanding? So, if I take F net, understanding net force, F net means net force. Net force must be equals to 0. If net force is 0, automatically who will be 0? Everybody. Yes, please.
Acceleration.
Acceleration 0. So keep in mind that, all of you. So if you want to find the net force, then you have to add the individual forces. That is what we have to remember it. So totally, if you add this, all the things, we all knows which is equals to F and which is equals to what is the answer? Fastly. Net force must be equals to how much?
0.
0. Okay? That is
0.
what. Net force must be equals to how much? 0. So whatever the forces you will get, if you will add it last and 100%, if it is, you can see the object is in state of rest, remains in state of rest. The object in state of motion remains in state of motion unless and until what? Everybody.
External forces apply to it.
External force is applied.
That is what this. So sum of the all external forces if we'll add, totally the answer is how much? Everybody?
0.
0.
That is only called as Newton's first law. Okay, Newton's first law says that the object which is said to be in motion, uniform motion. What motion, everybody? Uniform motion.
Uniform.
And okay, so always the net force is must be equals to how much, everybody? Net force must be equals to 0. So that is only called as Newton's first law. Unless an object which is in state of rest or state of velocity, unless it will experience by external force, is it possible to see the displacement? Anybody? All of you?
No, sir.
So if it is net force is 0, then the object which is in state of rest remains in state of what? Everybody? Remains in
Rest.
state of rest. Okay. If the object is in motion, that is what I'm saying. If the object is in motion, that is what? Uniform motion. So uniform motion means what? Constant velocity or variable velocity? Everybody? Uniform
Constant
velocity. Yes,
Constant
please.
velocity.
Motion, so that it is having the, what is that, everybody? Please respond. Contact
Velocity.
velocity. That is what you have to remember. Clear, everybody? All of you?
Yes, sir.
Yes, that is what it is. So, as we all knows that if you take, for example, speed, then what is happening here? Is there any change in direction? Speed means, yes, please. So, velocity means every time the direction may change or whatever it is. So, the object which is said to be in motion remains in motion. The object which is in state of rest remains in state of rest unless until they affected by what? They will be affected by external force. Clear? So that is only this F net is 0 in physics terminology, we used to called as, all of you, it is known as equilibrium. What is that, everybody? It is known as
Equilibrium.
F net is equals to 0 is called as equilibrium. And you remember first law also we can call it as what? Also called
Law of inertia.
law of inertia. Very, very important. That's all. Then we have to solve with the help of first law. We have to solve many sums and we have to find the tension. Okay. So that is what is our duty. Okay. All of you. So till here, everything perfectly. Anybody having any doubt, you can let me know or else we'll continue. Clear, everybody?
Yes, sir.
So F net acceleration or net force is 0. That is only called as Newton's first law. Unless and until an external force is applied, the body which is in state of rest remains rest. The body which is in uniform velocity remains in uniform